In this section, we're going to take a look at notes for section 7.3. We're going to take a look at all the other trig functions in addition to the sine and cosine. So what are all the trig functions? Well, if we take a look at, based on a right triangle, again with A, B, C being the angles, small case a, small case b, and c being in relation to angle A, little side a is the side opposite, b is the side adjacent, and c is the hypotenuse. We saw from the last section that the sine of the angle is a over c, cosine of the angle is b over c. There are actually 6 other ratios that we can get from this triangle. If we take the sine of the angle a over c and write it as the reciprocal, c over a, the reciprocal of the sine function is called the cosecant function. So the cosecant of our angle is equal to c over a. And sine, opposite over hypotenuse, so cosecant is hypotenuse over opposite. The cosine of our angle is adjacent over hypotenuse. If we take a look at the reciprocal of b over c, that's c over b, the reciprocal of cosine is called the secant. So another way to think about the reciprocals, the cosecant is CSC is the abbreviation of angle A is 1 over the sine. So the reciprocal means 1 over. The secant of angle A is 1 over the cosine A. So these are called functions that are reciprocal to each other. The third trig function, we have sine, cosine, AC, B over C. What we don't have yet are the relationship A over B and B over A. So the next trig function we're going to look at is the tangent of angle A. So the tangent of angle A is the opposite side over the adjacent side. So tangent would be opposite, which is A, over adjacent, which is B. Then the reciprocal of the tangent is called the cotangent. So the cotangent of the angle would be the reciprocal B over A. The notation is cotangent A would be 1 over the tangent. So we have 3 different trig ratios, sine, cosine, and tangent, where you can take ratios of different sides, A to C, B to C, and then A to B. And then those 3 trigonometric ratios have reciprocal functions called the cosecant, secant, and cotangent. So there are 6 trigonometric ratios in a right triangle, and therefore 6 trigonometric functions. Whether they're on the unit circle or in a right triangle, those are the 6 functions. So the tangent is also, can be written in relation to sine and cosine. So the tangent of the angle, if you take the sine divided by the cosine, A over C divided by B over C, you get A over B. The tangent is also the sine of A divided by the cosine. That means the cotangent is the reciprocal. That could also be cosine of A over the sine of A. So if you know sine and cosine, you can get the other 4 trigonometric ratios. So that's what the following describes. So the tangent is sine divided by cosine. The secant is 1 over cosine. Cotangent, cosine over sine. Cosecant, 1 over the sine. So if you think about these on the unit circle, let's take a look at an example. We have the point square root of 2 over 2, negative square root of 2 over 2 on the unit circle. Find sine, cosine, tangent, secant, cosecant, and cotangent of angle T. And notice we've got angle T. It doesn't matter what the angle is. We're trying to find the trigonometric ratios. So T is a negative angle. We're rotating actually negative pi over 4 or negative 45 degrees, okay, because it's one of our exact values. But I know that the x-coordinate is equal to the cosine. So I know the cosine of angle T is equal to the square root of 2 over 2. I also know the sine of T because that's the y-coordinate, negative square root of 2 over 2. The tangent is equal to the sine divided by the cosine. So I take the sine, negative square root of 2 over 2, divided by the cosine, square root of 2 over 2. Anything over itself is 1. We have negative divided by a positive. So the tangent of angle T is equal to negative 1. Once I have the sine, cosine, and tangent, I can get the reciprocal functions by taking the reciprocals of each of these. So the reciprocal of sine is the cosecant. So the cosecant of t is equal to 1 over the sine. So 1 over negative square root of 2 over 2 gives me the reciprocal, negative 2 over the square root of 2, and then I need to rationalize the denominator. So I end up with negative 2 square root of 2 over 2. The 2's cancel, and I get negative square root of 2. So the cosecant of t is negative square root of 2. The secant of t is the reciprocal of the cosine. So I've done my work here. The cosine is positive square root of 2 over 2. So when I do all this work, I'm going to end up with positive square root of 2. Then the cotangent is the reciprocal of the tangent. So the reciprocal of negative 1 is negative 1. So those are the 6 trig functions of the angle given the coordinate on the unit circle. Because since I know that the coordinate corresponds to the cosine and the sine, I can get everything else. All right, let's take a look at another example. If your angle is 7 pi over 6, then find tangent, cotangent, secant, and cosecant. So pi, or the angle, 7 pi over 6, is one of the angle measures on our unit circle. So if I know the sine of the angle, let me put the angle in there. If I know the sine of 7 pi over 6, and I know this cosine of 7 pi over 6, I can get all of the other trig functions. So this is where the unit circle comes in handy. So you open your unit circle, find the angle measure, 7 pi over 6, that's 210 degrees. The cosine is negative square root of 3 over 2, and the sine is negative 1/2. So if the sine is negative 1/2, cosine negative square root of 3 over 2, once I know what these two coordinates are, I can get everything else. So the tangent of 7 pi over 6 is going to equal the sine divided by the cosine. That's negative 1/2 divided by negative square root of 3 over 2. 1/2 divided by square root of 3 over 2. The 2's cancel. I get a positive 1 over the square root of 3. Rationalize the denominator. I end up with square root of 3 over 3. So the tangent of my function is square root of 3 over 3. The cotangent is the reciprocal of the tangent. I'm going to use this step right here, 1 over the square root of 3. The reciprocal of that is the square root of 3 over 1, which is the square root of 3. The secant of 7 pi over 6 is 1 over the cosine. So that's going to be 1 over negative square root of 3 over 2. So that's going to give me a negative 2 over the square root of 3. I've got to rationalize the denominator. So I take negative 2 over the square root of 3 times the square root of 3 over the square root of 3. And I get negative 2 square root of 3 over 3. So the secant is negative 2 square root of 3 over 3. And last but not least, the cosecant is equal to 1 over the sine. The sine of my angle is negative 1/2. So 1 over a negative 1/2, the reciprocal of negative 1/2, is negative 2. All right, so the next part, just to take a look, of the following trigonometric functions, since all 6 trig functions depend on sine and cosine, then the following trig functions are positive in each quadrant. So in the first quadrant, all 6 trig functions are positive. In the second quadrant, remember that cosine is negative, so everything that involves cosine is negative. So I've just listed the positive. The sine and the cosecant are positive in the second quadrant. All of the other trig functions are negative. In the third quadrant, the tangent and the cotangent are positive. The other 4 functions are negative. And in the fourth quadrant, the cosine and the secant are positive. The other trig functions are negative. So if you've got, an example, if theta equals negative 11 pi over 3, then find exact values for the following. If the trigonometric function is undefined, for theta equals negative 11 pi over 3, enter does not exist. So we need to figure out the sine and the cosine of negative 11 pi over 3 so that we can get everything else. All right, so where does 11 pi over 3 is not a value that's on your unit circle. Okay, we have 11 pi over 6, but we don't have 11 pi over 3. So we have to find a coterminal angle that is on the unit circle. So what's a value coterminal with negative 11 pi over 3? So remember, 1 revolution is 2 pi, okay? So if I'm going to rotate 2 pi over 1, that's the same thing as 6 pi over 3. So if I'm rotating 11 pi over 3 minus 6 pi over 3, I get 5 pi over 3. Or maybe let me think about this a little bit different way. Let me take the negative 11 pi. Actually, it's just one way or the other. So a negative 11 pi over 3, and I go around the circle once. Add 2 pi over 3, and that's, 6 pi over 3, which is 2 pi. So I get negative 5 pi over 3. So rotating negative 5 pi over 3 is the same thing as going all the way around the circle 2 pi and then another 5 pi. So where does negative 5 pi over 3 land? Okay, so I'm going around the circle 11 pi over 3, around the circle once, and then I'm going another 5 pi over 3. So what does that correspond to? So on the unit circle, 5 pi over 3 there's 5 pi over 3 is 300 degrees. Okay, so if I'm rotating negative instead of positive, then I'm going around this far and then another 5 pi over 3, which means I'm going to actually land not at 5 pi over 3, I'm going to land up here at pi over 3. So negative 11 pi over 3 is coterminal with pi over 3. And since it's coterminal with pi over 3, then you would find the sine and cosine of pi over 3, and then use that to find the secant, cosecant, tangent, cotangent, just like we did up above. So this one had an extra step. If it's not on your unit circle, find the angle that it's coterminal with. All right, last, there's something called even and odd trig functions. Okay, an even function is one where f of negative x equals f of x. An odd function is where f of negative x equals negative f of x. So on the unit circle, cosine and secant are even. Why? Because if you rotate negative, you get the same value as if you rotated positive. So let's take a look. Let me just use the unit circle. So if I rotate positive pi over 6, my value is square root of 3 over 2. If I rotate negative pi over 6, square root of 3 over 2. The cosine is the same if you rotate positive or negative. Then functions are odd functions. All of the other functions are odd. If you rotate negative for sine, you're going to get a negative value for sine. Same for tangent, cosecant, and cotangent. So if you look on the unit circle, for the sine, if I rotate pi over 6, the sine is a half. If I rotate negative pi over 6, the sine is negative. The sign is opposite. And then the other identities we have listed, we call them the fundamental identities, are the ones that we started off with. Okay? So if you want to evaluate cosecant of 7 pi over 6, that's the same thing as taking 1 over the sine of 7 pi over 6. If you want to use identities to simplify an expression, secant divided by tangent, write them in terms of their sine and cosine. Secant is 1 over the cosine divided by tangent, which is sine over cosine, and simplify. That would be 1 over the cosine. Dividing fractions means multiply by the reciprocal. That would be cosine over sine. The cosines cancel. I get 1 over the sine, which is actually the cosecant. So secant divided by tangent is the same as the cosecant. And then another example, simplify tangent times the cosine. Rewrite them in terms of sines and cosines. Tangent is the sine divided by the cosine times the cosine. These cancel, and we end up with the sine. So we use identities, or we use these to simplify expressions by rewriting them.